All right, we're going to begin with a review of the levels of measurement. Whenever we talk about data classification, which is really our kind of our last step in map reading or spatial data reading and interpretation, we need to think again about the basic characteristics of how we measure data. And so what I want you to think about are the four levels of measurement: nominal, ordinal, interval, and ratio. Let me go through these first, and then we're going to look at examples of each. So nominal levels of measurement simply mean to classify things into different categories. So we can say apples and oranges, pears, grapes, or we could say residential, business, commercial, industrial. Those would be, for example, planning classifications or land zoning classifications. We might say habitat and not habitat, an either or category. But in no case can we say one is better than the other or greater or less. In other words, we can't order them. They're simply different. In contrast, ordinal data allows us to rank things to say good, better, best, or weak, moderate, strong. But while we can order them, the interval between ordinations is unknown. So in other words, if we say weak, moderate, strong, we don't really know the distance between weak to moderate, nor moderate to strong. We don't really even know if those orders have an equal value between them. Now, once we move into a known interval, that is 1 to 2, 2 to 3, 3 to 4, we're going to say that's interval data. Now, the important thing about interval data is that in many cases, while we know that the intervals are equal, we can't necessarily make ratio interpretations. In fact, we can't at all. So in other words, to say 1 to 2 is an interval of 1, and 100 to 101 is an interval of 1. What we really can't say is what those two represent in terms of a ratio. And the way I want you to think about this, the classic one is, of course, temperature in Fahrenheit. So we can say that 50 degrees Fahrenheit to 60 degrees Fahrenheit is an interval of 10 degrees. Furthermore, negative 10 degrees Fahrenheit to 0 degrees Fahrenheit is 10. But what we really can't say is 50 degrees Fahrenheit is twice as hot as 25 degrees Fahrenheit, because in fact it really isn't. Remember that the absolute zero origin is not 0 degrees Fahrenheit, and so we can't really work with it that way. Now, true ratio data means that we know both the interval, that is, each interval is equal, and in fact we know the origin. So in this case, if we say population within blocks, it is possible to have a population in a block of 0. In fact, we know that that origin is there. Furthermore, if we have 100, we know that that is 100 units, people, that is, greater than that origin point of 0 people. And in fact, we can say that 50 people is twice as many people as 25 people. So therefore, we can create a ratio. Now, let's take a quick look at these types of levels of measurement. And from class, we had looked at this one, mapping segregation. And so in fact, in this case, what we are doing here is nominal levels of measurement. We have for each census group, and one dot represents 120 people, each color on the map designates a different named category. That is Black, Hispanic, Asian, White, and other. So clearly, and we would never suggest that there's any ordinal difference between the races, but they are represented differently. Okay, so again, no ranking, but different, nominal or named differences. Now, in contrast, what we can say then here, this is the spread of drought across the United States, and what we have here is drought severity, and in this case, we can say the drought is less severe, that is the light cream, to more severe red. And in fact, we can say that less to more is ordered, but we really don't know the difference between the steps of less and the steps towards more. So this is ordinal data. Now, in some cases, ordinal data can be weakly ordered, That is, we simply say good, better, best, but there's no real underlying numerical values. Or we could say, in fact, that these are based on numbers, A, B, C, and D, but the numbers are not explicit in the data. Now, we're going to go up to kind of the last one here. And in this case, what we're looking at is, again, absolute population. This happens to be in an area in Illinois. And in this case, we actually have a quantity that has an absolute zero. This is population in each block group. The lowest value could be 0, and the highest value is 1,591. Now in this case, it is both interval, the interval is fixed, and it is ratio because we know the origin point, which is 0. So the next time a video comes up, we're going to be looking at how we then classify each of these levels of measurement. We'll see you then.